Hello everyone and welcome back to another brand new tutorial. So in this tutorial, I'm going to discuss about how can you classify the images of brain tumor using deep learning. And in this case, you're using Python, Tensorflow, Keras, OpenCV, and so on. I already uploaded a video in my YouTube channel. This is the demo video for this brain tumor image classification. And we are actually using the Flux framework to actually make an web applications. And I already created a separate playlist for that, deep learning for healthcare. And you can also check out this demo video. Link will be in the description. You can check it from here. So let's get started and jump on the code. But before jumping on the code, we need to actually check out where you can find the data set for the brain tumor detections. So for this brain tumor detection project, we're actually using this data set, and the data set is from Kaggle. Okay, so you can see here there are nothing but 3016 images. Okay, and there are some labels here also on folder. And as you can see, this is the image for no brain tumor. You can see here. And if I go down, and as you can see here, there are some images for ES1. Okay, this one, images. There are another one data set here, as you can see, a brain tumor images for the brain tumor detection. The problem is there are a few number of data. That means there are only 253 images. Okay, so for that, we are not actually going to use this one. We are going to use this BR35H brain tumor data set, because of there are a lot of images. And you can also see on the next few tutorial that how can you actually use data augmentation to actually generate some amount of data and make this one very powerful. Okay, so let's jump on the code. But before jumping on the code, I want to say one thing, that is, if you are new in my YouTube channel, so please do subscribe my channel and must hit the bell icon. And also check out the deep learning and the machine learning playlist from my YouTube channel. Link will be in the description. You can see here I uploaded so many videos here. You can also use this new image detection using deep learning, and this is nothing but based on the transform learning technique using BZ16. And you can also use see the real-time visit classification using CNN. It is the actual pure CNN. We actually use that. Also face mask detection. You can also check out all the video from here. So let's jump on the code. All right, guys. So now you can see here I actually downloaded this data set from Kaggle. So I'm going to now click here to extract this file. Okay. So when you actually extract this file, you can see here three folders: yes, no, and the predictions. And the prediction is nothing but containing some images with yes and no. And if I go on the yes and some images, you can see here it actually affected by tumor. Okay, that's my brain tumor. And if I go on the no, this is nothing but fresh brain. Okay. So now I'm going to create another folder called datasets. Okay, so now I'm going to actually copy or cut it or move it on dataset. Okay, now I'm going to click here and open with VS Code. Okay, so now you can see here our VS Code actually opening here, and also you can see here welcome to Kite for VS Code. This is nothing but extension on VS Code. It actually helps us to auto complete the code. Okay, but before starting this video, I want to say one thing, that is actually watch the tutorial till end, because watch time is more important. And if you don't interested on this topic, so you can skip this video and go through this video. Okay, no problem. Okay, so I'm going to click here to create a new file here. So let's say in this topic, we actually discuss about how can you train the model. And the next part, we actually talk about how can you test it out and how can you actually build our web applications. And further, we're actually trying to make one node application also. So let's say main, let's say train.py, like that. Okay, so now our job is we need to actually read these images from this folder, no and the yes. To actually reading all the images, we are going to use OpenCV. So that's why I'm going to import the CV2. So make sure that install Python and also this kind of library. Actually, I'm not going to actually discuss about this to actually all the things. I'm just going to actually do the coding. I'm assume that actually install all the library in your system. Okay, so I'm also importing the OS for operating system. Actually, you need to actually collect the data from folder. So that's why I'm going to import the OS. Okay, so now what you have to do, we need to actually initialize the path of the data set. So let's say path, or let's say image directory equal. Okay, so our directory is nothing but our data sets. Okay, this is nothing but our directory. So now we are going to actually create a list for all of the images inside the no folder. Okay, so let's say os.list_dir and the image directory, that's mean this directory, and the no. Okay, that's in plus no. Okay, I assume that you know the basic thing of Python's. How can you actually use this kind of system? Okay, so os.list image directory, that means no. Just need to go through this folder and create one list of all the images. So let's say no, let's say tumor images. Okay, sorry, images. And when you actually try to print it out, so let's say print, okay, print the no tumor images, Control S and save, and then run the code in Python terminal. So now you can see here, this is nothing but one list. You can see a list, okay, list. If I go up, and you can see here, this is nothing but one list. So now what you have to do, we need to actually iterate through all the value from here. But before iterating through value, I need to discuss one thing, that is I'm going to just copy these here, okay, Control C and delete this one. And I'm going to actually discuss about one thing here, because this is more important. So let's say path equal, I'm going to pass it here. Okay, so now the question is, inside this folder there are nothing but some images with JPEG. So when our Python interpreter actually get the extension as JPEG, it will try to read the images from the folder. Okay, so how can I actually get that the JPEG, the image is actual JPEG or not? Okay, so inside this folder, if there is a PNG images or T file, it not actually read that. Okay, so see how can I actually do this? So we are actually using the split function to actually split that. So when our Python interpreter actually get the dot, then it will go to the 0 to 1 position and it will check that it's JPEG or not. Okay, so if I try to print this one, see, okay, see, and okay, listen carefully. Okay, you can see here, this is nothing but JPEG. So when we actually get this extension, then we are going to read the images from folder. Simple. Okay, so now we actually going to iterate to all the images from this no tumor images. Okay, so let's say for, okay, I, and you're also using the enumerator to actually get the ID from here. That's mean how many images. You can also actually, when you are trying to plot something, that's mean you are not going to actually plot the number of images inside this folder, you can use these enumerate things. So I and images, let's say images, let's say name in enumerate, and inside this you need to put here the path. That's mean this path. So this path is nothing but this one. No. Now we need to check that our image is JPEG image or not. Image name, okay, dot split. So which one? Dot and 1 equal JPEG. Then we are trying to read the images. So for reading the images, we are going to use OpenCV. So let's say image equal cv2 dot IamRead. Simple, IamRead. Okay, we're going to read that images. Then our image directory, that's mean this image directory, the no, that's mean this no, we're going to go here, the no, from the no one. Then we're going to actually iterate to the images from here. Okay, sorry, this is nothing but the backslash. Okay, and plus what is this, is the image name, this image name. Okay, so we actually read the images. So now what you have to do, we need to actually convert this image in RGB. Why? Because you know OpenCV actually read the image in a BGR format. Okay, we're going to actually train the images in RGB channels, that's been red, green, and blue. Okay, so now what you have to do, you can also use the CB2 or CBT color BGR to RGB, but in this case I am actually show you one thing that is more interesting. I'm going to use the PILU library for that. So PIL, I'm going to import the image. Okay, so how you actually import the image, that's mean actually read the image, we need to actually use make this image in array format. Okay, see how can I actually do that. So image dot, sorry, this is not image. Okay, this should be this one, image, this image dot from. Okay, from, so which one? From array. Okay, now I'm going to pass here the image, this image, and simply for the quotations we are going to make this RGB. Okay, and say bit 1. variable called images. So our image is converted on array. Okay. So now what you have to do, we need to actually resize the images, and in this case we are actually using 60 cross by 60 cross. Okay, so if I go here, you can see here this is nothing but it's not actually 64 by 64 images. So that's why you need to actually resize the images for the purpose of the model building. Okay, so that's why I'm going to use the not actually using CB2. You can also use CB2.resize. You can actually resize that, but I'm going to actually show you another thing here. So let's say image. So image, okay, image dot resize. Okay, resize the images, and you need to put here the size of the images. So our size should be, let's say, 64 cross 64. This is the size of the images, and you can also make it as image. Okay. So now we need to actually separate the images. That means why? In some levels. So when actually our model actually get the image level as 0, that means this is nothing but no images, that means no brain tumor. And when our model is actually predicted the image as 1, that means this is come from the ES1. Okay, so that's why you're going to actually convert this image in the dependent and the independent variable. Okay, so for that I'm going to actually create one list. Let's say dataset and another one for the level. Okay, this is nothing but a level. Okay, so I'm going to actually append the dataset here. So dataset dot append. I'm going to actually append the image in a Numpy array format. Okay, Numpy array, so np dot array. Okay, and the images. So now you need to actually import this Numpy here. So let's go up and import Numpy as np. Okay, and also you need to actually append these on. Okay, so label dot append. So how you actually put here 0, that's means this is number for no. Okay, no brain tumor. Okay, now we need to do the same thing for the ES. So I'm going to just copy this out, Control C, and I'm going to paste it here. Okay, let's make it as ES. Okay, and also this one ES. Okay, I'm going to copy this out, Control C, and I'm going to paste it here. Okay, and do some changes on here. Okay, so all are okay. So this should be the ES, and all are same. It should be the ES, and this one also ES, and level is nothing but 1. Okay, okay. So now let's try to print the data set and also try to print the level. Okay, see how it actually look like. Okay, print it here. Okay. Okay, so non-type object has no attribute array interface. So all right, and now you can see here we actually do one mistake here. So this is nothing but for the actual path. This one like that, and this one also like that. Then now it actually work here. Control S and save and run the code. Okay. Okay, it will take few seconds to actually print the data set, also the levels. Okay, so now you can see here it actually running, but no error. Okay. So now you can see here there are nothing but multiple error, not error, actually array. Okay, so you can see here it actually printing all the images array line by line, and with levels. Okay, so huge line of level. Okay, so I'm going to actually kill this terminal. Okay, and this one. Okay, we can also print out the length of the levels and also the data set. So let's try to print it out the levels, length of the levels. Okay. Control S and run the code on the Python terminal and see. Okay, okay, this is actually executing. Okay, what? Okay, so now you can see here this land is nothing but 300. That's been not 300, actually 3000. That's mean there are nothing but 3000 images. It's containing JPEG images, JPG, and is folder. Okay, and also if I trying to actually print out the length of the data set here and see how many actually what do you call, okay, don't uncomment this line, save and run the code. Now you can see here one interesting thing here, the length of the data set and the length of the levels. The data set is nothing but the Numpy array, as you can see before. See, the level and the data set length is always same. Okay, that's when you are actually accessing all the images from the folder correctly. Okay. So now what you have to do, we need to actually convert this data set into a Numpy array. Okay. So for that, we are going to use np.array, and inside this, you need to put here the data set. Okay. And also do the same thing for the label. Okay. So this one for label. Okay. So data set, and this one for label. Okay, this one label. Okay, so now we need to actually what do you have to do, we need to actually convert these images. We actually convert this image into Numpy array. So now we need to actually train divide this data set into train, test, and split. So for that, I'm actually importing from the sklearn, that's in scikit-learn. So from sklearn dot model selection, I'm going to import train, test, and split. So I'm going to actually split the data set into 80% of the training and 20% for the testing out. Okay, so let's say x train, okay, x test, okay, this one, and the y train and the y test, okay, this one test. And inside this train, test, and split, I will take some few parameters. So first one is the arrays. So the arrays and the test size. The arrays is nothing but the data set and the labels. That's an x and y. So our data set is nothing but the x, and this is nothing but for the y. Okay, and the test, that's in our test size. That's mean the size is nothing but 0.2. That's in 20% data for the testing. Okay, we also put here the random state. Okay, that's in random state at 0. Okay, for that. Okay, so you actually train out this divided this model into train, test, and split. So if I'm trying to print the shape of the x train, okay, shape of the x train, let's try to print it out. See, shape, and run the file, Python file. It will take few seconds because you actually loading all the images from the folder. That's why it actually takes few seconds to actually load that. Okay, see, this is nothing but the images. Okay, shape. Okay, this is nothing but the number of images on the train, and 64 means this is the size, 64 cross 64 images, and 3 is nothing but the channels. The channels is red, green, and the blue. That's the RGB images. Okay, so we are successfully actually reshaping that. That's mean this types of thing. Okay, see, when you actually reshape, okay, the reshape is actually look like that, and number of images, the image size, or you can say image width, and the image height, and the number of channels. Okay, okay, so these types of reshape, as you can see here. Okay, so I'm going to actually comment this line. So if I trying to print also the shape of the x test, then you can see here, not sorry, y train. Let's see, I actually run the code on Python terminal. Okay, so please listen carefully because I'm going to actually discuss all the things in details. If you're a beginner, you can also watch the tutorial and you can actually learn a lot of stuff here. Okay, so now you can see here y train also the same. Okay, so now when we are trying to print for the testing one, that's been x test, see one thing, x test, and also the y test, then you can see here. Okay, okay, run the code, the Python terminal, and you can see here one thing, cool, interesting thing that you can see here. If I go up, you can see here the data set length is nothing but 3000. Okay, 3000. Okay, so now you can see here the data set is actually divided into 80% and 20%. That means there are 2400 data, and there is nothing but 600. So total is 3000. Okay, and image are nothing but size of 64 cross 64, and the number of channel is nothing but 3. Okay, we are done. Okay, so I'm going to actually close this out. Okay, I'm going to comment out this line here. Okay, okay, so now it's time to actually normalize our data for training purposes. So that's why I'm going to actually normalize the data. So let's say x train equal. So for normalizing the data, we're actually importing one class from here, from Keras Okay, from keras.utils, we're going to import the normalize. Okay, this one normalize. You can also import the TensorFlow here. So let's say import TensorFlow STF, and also from TensorFlow we're going to import the Keras. Okay, this one you can do that. Okay, so let's use the normalize one. Okay, so let's import here normalize. Okay, and inside this you need to put here the x string, and the axis is nothing but 1. Okay, now we need to do the same thing for the what do you call it, x test. Okay, and this one for, oh sorry, this is nothing but x test. Okay, so this is nothing but one binary classification problem, so that's why I'm not actually converting this y in a categorical format. Okay, I'll be explaining all the things in details, don't worry what I'm actually saying that. Okay, so now it's time to actually build up our models. To build up our model, we need to actually import something from here. So let's import it out here. Okay, so let's say from keras dot model, we're going to import, let's say import sequential model. Okay, and also from keras dot layers, I'm going to import the con2d, this one con2d, and also let's say max polling 2d. Okay, max polling 2d, and I'm also going to import the activation functions, that's activations, and also the dropout, and also the flatten here. Okay, and another one is nothing but the dance layer. Okay, you can also actually using import this from another line. So let's see how can I actually do that. Simple, just see here, layers. I'm going to import this one, activation, dropout, and the flatten. Okay, okay, so our import is done. Now we need to actually use that. Okay, so let's build our model. Okay, so let's say model building. Okay, okay, let's build it out here. Okay, so for this we are actually building one sequential model, so that's why I'm going to say here model equal sequential. Okay, sequential model. Okay, now we are going to add the first layer here. So model dot add, it actually simple to actually add model layer in Keras. So let's say con2d, this is con2d, this one con2d, actually import it before. Okay, and also it will take the parameter. So first one is nothing but the filter, so our filter is nothing but, let's say 32, and the kernel size we're actually using 3,3 kernel, and the straights you can also put it here, no, don't worry on that, and padding and the data format, dilation rate, groups, activations, number of bias, that means so bias, kernel initializer, and you can see our glow dot uniform. So in this case we are actually using the uniform, kernel regularizations, and also bias regulation, and all the things stuff. So first, for first layer you're actually using you actually put here the shape of the import. Okay, so you actually do the stuff for hard coding. You can see your 64. So you can actually create a variable to actually import the images. So let's say import size equal, let's say 64, then we can actually use this one. Okay, use this one here. Okay, so let's use this one, control V. Don't, so when you actually change this input size variable, and this size is automatically changed here. Okay, okay, so see, so this is 3x3 filter. Now what we have to do, we need to actually put here the shape. Okay, that's been input shape, this one, the input shape. Okay, so input shape is nothing but our input size, that's been our input size, comma, okay, input size. Why? Because we are actually in 60 cross 3. Okay, comma 3. This is nothing but our input size. It's like that, 64 comma 64 comma 3, like that. Input size 64, input size 64 comma 3. It's in this one, our images. Okay, so now add the activation function here. So I'm going to add, okay, I'm going to add the activation functions. So activations. So for the activation, you're actually using the ReLU activation functions. Okay, and for that, you're going to actually add one max pooling layer, max pooling 2D, and the pole size is nothing but, let's use 2,2. This is nothing but a random CN model. It's going to build that. I will just copy this out, Control C, Control V, and Control V. Okay, so let's make it as 64, and let's remove this one. Okay, this one, and let's say kernel initializer. We're actually using the uniform. Okay, this is nothing but our kernel initializer. Okay, this is nothing but a random model. We're actually using that to actually train our models. Okay, so let's copy out from here. It's also same as that. Control C, and we're going to paste it here. Okay, so now we need to actually flatten here. Okay, why? Because we need to actually make this all the images in one vector. Okay, that's been linearly. So that's why I'm going to actually using the model.add. Okay, I'm going to add one dance layer also here. Okay, so add one flatten layer here. So let's say flatten. Okay, this one flatten, and finally I'm going to actually add one dance layer also with 64, and also I'm going to import here one activation functions. So activations, and I'm going to put here ReLU activation function here. This is nothing but a simple simple CNN model, and again I'm going to put here one output layer, dance. Okay, sorry, dance layer with output. Okay, dance layer. Okay, sorry, this is nothing but add, and inside that I'm going to put here the dance, and it will take the parameter called 1. You can also put here one dropout here to actually dropout to actually minimize the overfitting problem or underfitting problem here. And also I'm going to actually add model.add finally the activation function we're actually using, that is called sigmoid. Okay, sigmoid. Okay, so now the question is, why should you put here 1 here? Why should not 2? Because our output is nothing but 2, no and yes. Because of we are actually using the binary classification problem. I will talk about that. Why not we actually convert this Y train and the Y test in a categorical format? Okay, that's when we're actually using a loss as a binary cross entropy. Okay, so that's why we put here dance as 1. But how are we actually using categorical cross entropy? Make sure that use the 2. That's the number of classes. But because we are actually using the binary classification problem, so that's to put here 1. Okay, listen carefully. One thing, that is how are we actually using binary cross entropy as a loss. That's in loss. Make sure that use dance layer as 1. So how we actually use the cross entropy using the number of classes, that's been 2. Okay, and also the activation function, that's in last layer, make sure that for the binary classification using sigmoid. Okay, and for the cross entropy, so make sure that use softmax. Okay, softmax activation function, make sure that use that. So for this, I'm just using one binary classification on that. In the upcoming video, I actually talk about using this cross entropy. Okay, that's been categorical cross entropy. Sorry, this is nothing but the categorical cross entropy. Okay, now what you have to do, you need to actually use this one. So model dot, you need to actually compile the model. So compile the model, it will take the loss as binary cross entropy. So make sure that put here binary cross entropy. Okay, so cross entropy. Okay, and the optimizer you're going to use Adam, simple. That's the most popular optimizer. You can also use RMS Prof, something else. And the matrix, you're going to actually using the accuracy matrix. Okay, okay, done. So now we need to actually feed the model here. So I'm going to just put here the model.feed here, and I'm going to put here the X train, okay, and the Y train, and the bass size, that means number of basses. So let's put here 16 basses. You can also use 32, 64. It's up to your GPU. If you have a more amount of GPU, you can use bass size 32, 64, 20. But my favorite is bass size is nothing but 20, but I'm using 16 here. Okay, verbose. Let's say verbose as true or 1, whatever, true or 1, and the number of epochs. So let's say around the epochs for 10 epochs first time, and let's say validations. You can also use callbacks here. I'm not actually using that. So validation data. Okay, so I think it will work here. Yeah, validation data. So let's go down and go down. For the validation data, we're actually using the X test. So X test. Okay, sorry, X test. What is happening here? And the Y test. Yeah, and let's say make the shuffle as false. So you don't need the shuffle here. You can also make it as true, no problem, it's up to you. False. Okay, so now we can actually save the model in our folder. So let's say brain tumor .is5. okay, so how many epochs? Let's say 10 epochs. Okay, so okay, now we need to actually make this out as is5, not is4 here, and run the Python code in terminal, and it will actually train up the model here. Okay, so you can see here successfully open the dynamic link Numpy Coda 64101 DLL, actually using the Coda and the NVIDIA GPU, and it will actually don't take much more time to actually training up the model. So you can see your number 1 epoch is actually starting. We actually train the model for the number 10 epochs, and accuracy also increases and loss is also decreases, as you can see here. So I will actually pause the video. So alright guys, so now you can see here our actually accuracy is nothing but 0.99% and our validation accuracy is nothing but 0.9750%. Okay, sometimes it's actually a problem for the overfitting, but not the much more problem here. Okay, so our model accuracy is good here, and it will take 2 minutes to actually train up the model in my system. Okay, so I'm using GPU here. Okay, so now let's talk about how can you actually use the cross entropy and make this dense layer as the 2. Okay, so if I go up, now what you have to do, we need one thing to actually import here. So utils, I'm going to import to categorical. So to categorical, how you actually using a categorical cross entropy. So if I run the code with using the 2 dense layer, just see, using the 2 dense layer, and also make the binary classification, binary cross entropy as the categorical cross entropy, and run the code. Now you can actually see here one error. Okay, one error is actually happening. It actually load it, but it will give you one error. So what is the error? You can actually see here. Okay, just wait, and it will take few seconds to actually load that. Okay, so now you can see here this is nothing but one error. Shape is 16,1 and the 16,2 are incompatible. Okay, I think I actually pronounced that. That's mean this is nothing but the 1, this is nothing but the 2. We give here 2, but it will take 1. Why? Because we don't actually convert our Y train and the Y test in a categorical format. So for that, we need to actually convert this Y train and the Y test as a categorical format. Okay, so let's convert it out. So Y train equal to 2 categorical, and inside this you need to put here also the Y train and also the number of classes. Okay, so number of classes is nothing but 2. So to do the same thing for the Y test. Okay, this is nothing but the Y test, and this is nothing but the Y test. Okay, so for the categorical cross entropy, you need to actually use the activation function, the last layer, as the sigmoid activation function, and all are set. So let's make it at epochs for, let's say, categorical, So how you actually train the model, you can see here one epoch, that's mean this is not the model file. You actually use this model file later on. So save and run the code and see if we get any error or not. Okay, it will load it. I think you don't get any error here because all are set here. We normalize and make this data in the categorical cross entity, and the number class is 2. And also the dance layer, we make it as 2. Okay, all right, you can see here our model is also training. Okay, you can see here. Okay, so I will actually pause the video. Okay, so now you can see here our actual model training is done. Okay, so in the next few third, we actually talk about how can actually test it out this model using some few images, and then in the part 3, and we are going to actually make one web application using Flux framework, and maybe in the part number 4, we are actually trying to build one Android application on that. Okay, so this tutorial, hope you'll enjoy this tutorial, and make sure to subscribe my channel and don't forget to hit the bell icon for never miss any update. And I'll be back in another tutorial that's in part number 2. Thank you and bye bye.